Well, I'm down here a little early because 10 o'clock, early for me. I'm retired. I'm starting some experiments. I'm going to be capturing some data, and that's going to help us come up with a better solution. I was up late last night, actually in the middle of the night, with an idea, thinking through all of the bits and pieces and what we've done so far. And there's this diode blob, more or less, a diode blob that we can take from the track power to the motor controller that's going to the motor itself, which is a 5 to 15 volt DC, and I can rectify that out so I got a positive and negative signal coming out regardless of direction. We know that works. Andy's concern was that may put too much draw on the motor control board, and I'm going to determine what that draw is. With a 7805 or 6, we can turn that into 5 or 6 volts, which is plenty enough to run the relay. I can run that direct when the motor's on in either direction and fire the relay. That's what we need to do. The mission currently now is to say, how much load is a motor control board going to see, and how much can it really handle? I have damaged boards, I have melted solder, I have done some things you shouldn't do to these things. So what I'm going to do now is find out what and why. And I've learned through the research on the LEDs that milliamps is the term that we want to use on some of these measurements, but we can also look at amps and just keep it in the upper levels. So here I have a pretty standard armature. It's a Pullmore armature with some magnets, and it is the latest design, so it should be a free running, and it's going to be powered by my triplet PS305. Now bench supplies, power supplies are not cheap. This one was a good price for me, but it gives us controls and things that we don't sometimes really appreciate, and I'm learning just in the last few days more about this particular unit. This is the limited by the current, limited by the voltage, and this is the amperage, and this is you'd read that as 28 milliamps or 0.2 amps, and this is the volts that's sitting at. So it's sitting at that. Where it is, the volts is at midway on the fine and midway on the coarse. So this should be putting out about 15 volts if it wasn't current limited. The current limiting on the fine is in the middle, and the current limiting on the coarse is down to the lowest possible. So I'm only up here. So if I crank this up, this little one up, I get a very fine adjustment, and I can raise up the voltage, you see. But I can only go so far. Since this is a fine adjustment, I can only go up to 5.6. So now we want to see at what point will the motor start. What is the minimum current to get this thing going? And I'm going to start bringing it up. Now we're at 1 amp, 1.3. It will run at 1, but it won't kick off until 1.2 or 3. Okay, you understand that? So with this draw now, I'm going to say it has a 1 amp minimum. Now then, if I crank up keep cranking up the amps, and it can draw more now. When you see this switch from CC to CV. This is saying that the current is now limiting your speed. And in this one, if I go up a little more, you'll see it pops over to 0.9 and stays there. Now the voltage is limiting your speed. I'm already at 15 volts, so that's pretty fast, right? That's about as fast as, okay. All right, I gotta go, but I'll get back to this. But we're learning a little bit of technology. I kind of knew it, but I haven't really exercised that part of my brain in a very long time. Now I have to. So I've got to be studying the amps and getting the amps down, and I'll get back to you a little bit later. We have a serviceman here on the AC. Okay, that's it for the day, and I'll be back. Don't worry. Later.